Welcome, everyone. Welcome to the 2020 APEC Groundbreakers virtual tour by APACO UC. This year, our event will be the biggest one ever done with 174 sessions, including normal sessions, workshops, and hands-on labs from 123 different speakers over 11 days. Also, it will cover sessions on 4 different languages. Please remember to register to as many sessions as you can, and all sessions will be available for replay as many times as you want for 2 weeks after the initial session date and time. You can also interact with the speaker at any time during that 2 weeks by posting questions and comments directly in the playback session page, and the speaker will contact you and respond at your convenience and his convenience. Let me just change the slides. There we go. I would like to say thank you to our Oracle user groups and Java user groups that made this event possible, and also to our sponsors, Oracle Groundbreakers and CloudDB. Now for today's session, High Availability in Oracle Cloud by Aman Sharma. Please feel free to write questions at any time during the session using the Q&A tab of Zoom, the Zoom webinar, and the speaker will be answering them at the end of the session. If any issues during the presentation, please feel free to contact me at any time using the chat tab of the Zoom webinar. Just to make it that more clear, any questions to the speakers with regarding to the session, please use the Q&A tab, and Aman will be answering at the end of the session. You can write at any time. And if you have any issues with Zoom or have any questions about the conference, please feel free to contact me, the moderator, by using the chat. Now, without any more delays, I would like to leave you with this amazing session by Aman Sharma. Okay, Aman, I will stop sharing and you can start sharing and taking control.
Sure, just give me 1 minute. Okay, so now going for the sharing, and there it goes. Please confirm, Francisco, if you can see the screen and moving.
Yes, I can confirm I can see your screen very well and I can hear you properly. I will put myself in mute now.
Sure, thank you so much. All right, good morning, good evening, good afternoon to everyone who is joining in the session. I hope you're all safe. So this session, welcome to my session for high availability in Oracle Cloud infrastructure. So this talk is basically going to be about the know-how about what kind of things we do have available in terms of the cloud infrastructure to achieve high availability in terms of different aspects. Quickly about me, I have been working with Oracle database for some time. I'm an Oracle ace, and I co-author 2 books. The first one is with Francisco itself, and the second one with my friend Kamran. And I'm an Oracle ace. I tweet here, I blog here. That's pretty much it. So this slide is very important. The Groundbreakers is going to be a program run by Oracle ACE program. Groundbreaker Tour is basically maintained by Oracle ACE program with the support of all the user groups. So Oracle ACE program is basically the recognition program from Oracle. In case you're an individual who takes a lot of interest in sharing his or her knowledge with the peers, with the community in terms of any particular way, whether it's a blog, whether it's videos or conferences, presentations, anything. All of that actually can, be recognized by Oracle in the form of 3 tiers. ACE Associate, which is the first tier, ACE, which is the second tier, and the ACE Director, which basically is more of a formal recognition as a leader of your, as a leader by the Oracle for you in terms of Oracle community. If you know someone who is worthy of doing all these things, who is actually worthy of all these awards, and he's doing all these things, or if you think you are actually, doing all these activities, writing blogs, books, helping people on the forums, that's how I got started. And, so in case you're going to be actually having this thing with you, and you feel very, very energetic about doing all this, then you can nominate yourself onto the website. Otherwise, you can actually reach out to ACE directors, ACEs, or ACE associates to nominate you for the same. Okay, so starting with the high availability part. So high availability is something which is very, very important. And obviously high availability is something which is required, especially when we're dealing with the transactional system. So I just picked it up from the wiki. High availability is a characteristic of a system which aims to ensure that an agreed level of operational performance is always actually going to be there. So this is something which is going to be required in case someone wants to build a particular infrastructure or particular, set of systems which are going to be operational no matter what. Now, in simple words, this is basically what it is. You need to have the businesses available. You need to have the systems designed in such a way in terms of every aspect of the systems that they are actually going to be available and they are able to withstand the problems which are going to be there in terms of different parts of the building blocks. For example, there could be a problem in the host, there could be a problem in the database, so on and so forth. Now, whenever we talk about high availability, one of the major things which has to be there is that there should not be any single point of failure. So this is going to be important that when you're going to be building any kind of high availability solution, it should not really be having any point of time, any such kind of building block, which will be just one. That is why we're going to talk about that just in a minute. That is why the redundancy is so very important. And in terms of high availability, it is going to be important that whatever we do in terms of being the designers or the architects of such kind of infrastructures, this should be more and more transparent to the users. They are not really required to know the particular details of what we are doing and how we are actually doing it in the background for the systems to be in such a way that they're going to be available all the time. Now, the main three building blocks of the high availability is actually going to be redundancy, monitoring, and failover. And that's what we are actually, trying to put up over here. So obviously, if you're not monitoring what is actually going on, which component is working, which component is not working properly, obviously you will not come to know that things are actually working fine or not. Then redundancy. Now, redundancy obviously means that multiple components can perform the same task. The problem of a single point of failure is obviously going to be eliminated because redundant components can take over a task which is going to be performed, for a component which has already been failed. So obviously redundancy is going to be one of the major things about high availability or high availability service. And then the last bit is going to be the failover. So failover is basically the process by which a secondary component is going to take over and will become a primary component when the primary component actually, fails. Now, all of this is going to be important, but there are two more aspects which are really required in terms of the high availability: the recovery time and the recovery point. The major thing, or in simple terms, actually, the recovery time is basically going to be that how much amount of time we are basically going to take in order to get the recovery done, or the maximum time that we're going to take to get the recovery done. And the recovery point is that how much amount of data restoration we are actually going to be requiring to do to basically reach at this particular point. So obviously these two things should be considered. So our backups and such should be actually considered in such a way that these two particular things should be on point. Now, Oracle's infrastructure is built upon different components in terms of their cloud infrastructure. So the major thing where everything starts from is going to be regions. So we have regions which are basically the geographical areas around the world. There are different areas where there are different numbers of such regions actually exist. But in terms of regions, I'm sorry, my bad. There are different number of availability domains actually exist. So different regions have a component called availability domain, which is like data centers. And some regions they have one, or some regions they have maybe more than one data centers actually present. Now, what exactly is going to be an availability domain? Basically, it is a one or more data centers which are being located within a particular region. Availability domains are actually going to be isolated from each other. They are going to be fault tolerant, and they are not likely going to fail simultaneously because availability domains do not really share the physical infrastructure, for example power or cooling or the internet availability domain network and such, a failure which possibly may happen in one availability domain is likely to impact the availability domain of others, and they're going to be interconnected by a high bandwidth network in case you're going to be designing your components in terms of highly available way. Now, within the availability domains, this is how they're going to look like. Now, within the availability domains, we have further a subdivision of fault domains. So a fault domain is a grouping of hardware and infrastructure within an availability domain, and each availability domain contains 3 fault domains. So fault domains basically allow you to distribute your instances so that they are not on the same physical hardware within the same physical availability domain, or within a single availability domain. And as a result, if an unexpected hardware failure or a compute hardware maintenance that you're going to do is going to affect one fault domain, that does not affect instances in other fault domains. You can obviously optionally specify the fault domain for a new instance at launch time, or you can actually let the system detect it for you when you're going to design it, in terms of your creation of the instances. All the availability domains are basically going to be in a particular region, and they're going to be interconnected, as I mentioned, in terms of a high bandwidth network. Now, this predictable encrypted interconnection between the availability domains is going to be one of the first building blocks for both high availability and for disaster recovery. And in terms of the systems, when we're going to be having the systems, definitely we are going to be requiring to have the compute instances. So the compute instances are basically going to be the instances which are basically going to be placed within the fault domains in terms of an AD. And obviously fault domains make the applications go highly available. Now, in terms of the compute instances, you can actually notice that whenever there is going to be a compute instance, it is going to be placed in terms of a bunch of availability domains. So what we're trying to show basically over here, that we have one particular set of systems which are actually running, and they are running in terms of 2 availability domains. And this is one OCI region which is actually available. For example, this is APAC region. So this is actually having 3 availability domains, and we are actually using them. Now, in terms of the availability domains, or in terms of this particular infrastructure, there is going to be something which is going to be important. So if we go back, actually, each of these particular compute instances, they are going to have a private IP address. So they're going to have a private IP address. They can have a public IP address for sure, but it is not really recommended actually to basically have a public IP address. It is possible, definitely, but the primary IP address which is going to be assigned to these particular instances is going to be a private IP address. So if whenever you're going to make an compute instance inside a subnet of your AD within your particular OCI region, the primary address which is going to be assigned to them is actually going to be a private IP address. Now, taking it a little bit further, the compute instances can be assigned a secondary IP address as well. And this floating IP address of the compute instance, either the secondary private IP address or the reserved public IP address, they are going to be actually possible to have something called a floating IP address. Now, this is going to be an important thing in terms of high availability architecture design. Obviously, because if a compute instance has a problem and it has a secondary private IP address, you can reassign this secondary private IP address to a standby instance in the same subnet to achieve instance failover. So I'll repeat. Floating IP address is basically going to be given to the compute instances, and it actually helps in terms of getting the high availability solution possible for compute instances. Now, if a compute instance is assigned a secondary private IP address and it actually has a problem, you can reassign this secondary private IP address to a standby instance in the same subnet to achieve the instance failover. Now, we can have a reserved public IP address that can be persistent and can exist beyond the lifetime of the compute instance as well. So normally when we assign a public IP address to a compute instance, it is only going to be till that instance actually stays within our particular system. Once we remove it, it is actually going to be gone and new instance is going to get a new IP address. But a reserved public IP address we can actually give to the compute instance, and it can exist beyond the lifetime of that instance as well. So in case of high availability and maybe for failover scenarios, you can unassign the reserved public IP address from the primary instance and can reassign it to your standby. And you can obviously automate this particular thing as well. So the automation can happen with the help of the high availability services of Linux, for example, CoroSync or Pacemaker. They actually can help you in terms of getting this particular part taken care of. Now, in terms of the network, design in the OCI, the entire OCI network is going to sit on something called VCN, the Virtual Cloud Network. So a VCN is going to reside within a single region, but it can cross multiple availability domains as well. And to allow the access for the compute instances, there can be different gateways possible. For example, there can be an internet gateway which can provide a path for network traffic between your VCN and the internet. There can be a virtual router that can provide a single point of entry for the remote network paths coming into your VCN. And you can also use the DRGs, dynamic routing gateways, to establish a connection with your on-premise network, either via IPSec VPN or via the FastConnect. Now, if we do have this network actually in existence, definitely one of the things which is going to be required along with high availability is going to be load balancing. So load balancing, in terms of high availability structure is going to be, required. So basically what we do need to have this load balancing options available. It can provide us automating the traffic distribution from one entry point to multiple servers, which are going to be reaching to your VCN. This is going to be having the option to use public or private IP addresses and obviously to provision the bandwidth for that. It can improve the resource utilizations, and obviously it can support the routing of incoming requests to various backend seats. Now, the right size of subnet is going to be important. So each subnet in a VCN exists in a single availability domain and is going to consist of contiguous range of IP addresses that do not overlap with the other subnets in the cloud network, right? So the first two IP addresses and the last one in the subnet CIDR, they're going to be reserved by OCI networking service. You can't change the size of the subnet once it is going to be created. So do put this into importance that the size you need has to be thought out before the particular network is going to be or the subnet is going to be created. Obviously, consider the future growth of your workload and leave sufficient capacity to meet high availability requirements, such as, for example, if you need to create standby compute instances, you need to have, those particular headrooms available to do so. Now, in terms of the load balancing, we can have the load balancing available through public load balancers or through private load balancers. So if it is going to be a public load balancer, it is regional in scope and will require two subnets, each in a separate availability domain. As a result, public load balancer is inherently highly available across availability domains. And to achieve high availability for your systems, you can put systems behind a public load balancer. For instance, you can put your web server VMs as backend server sets behind the public load balancer. So public load balancers, they allow you to have the traffic accepted from the internet. You can create a public load balancer for that. Public load balancer service is assigned to a public IP address that becomes an entry point for your incoming traffic. And you can associate the public IP address with a DNS name as well from your DNS providers. Now, the private IP addresses are basically going to be where you do not need actually too many things. So when you create a private load balancer, the service requires only one subnet to host both the primary and the standby. So you can see that we only have one subnet, which we are using basically to have this primary and standby load balancers to be available. And private load balancers can be good. You can actually isolate your load balancers from the internet. You can actually simplify your security posture. You can create the private load balancers, for that. And the load balancing service assigns it a private IP address that is going to be serving as the entry point for the incoming, traffic. Now, obviously, in terms of having the systems in place, it is actually going to be required that when we are going to be into the network, we possibly should be having it through some kind of VPN. And that becomes even more important when the transmission is actually going to be happening through the public internet, which is not going to be a secure thing. So in terms of the client data centers to actually get connected to the OCI network, two options actually exist. One is going to be the IPSec VPN. So second is going to be FastConnect. So implementing IPSec VPN connections is actually going to be, you can do in terms of, you can say, the most easiest manner. I will not say easy, but this is going to be the option that you can actually pick more often. IPSec VPN is going to be more cost effective, and to enable the redundancy, each cloud infrastructure dynamic routing gateway has multiple VPN endpoints, so that each IPsec VPN connection, which consists of multiple redundant IPsec tunnels, they can use static routes to route the traffic. And to ensure the high availability, you must set up the VPN connections availability within your internal network to use either path when needed, to connect to your particular Oracle Cloud region. Now, implementing this IPsec VPN for redundancy part, multiple endpoints are going to be there, and obviously you need to have VPN connections availability from your system. Now, if you want a dedicated, you know, highway sort of, or a dedicated line sort of, to actually connect from your particular data center to the Oracle's cloud region, a better option can be something called FastConnect. IPsec VPN is actually going to be free, but because it is free, they do not really have the option to provide you any sort of SLA for it in terms of performance. But this can change when it actually comes to the FastConnect. So that FastConnect is basically a dedicated private connection, and that means this is going to be something which is like having a private VVIP lane from your data center to the Oracle's cloud region. And you can actually get much higher bandwidth over here, basically, to get a more reliable and a more consistent networking experience. Now, it does support private peering, it does support public peering, and it actually supports both as well. Now, if you're going to be using private peering to extend your existing infrastructure into a VCN in Oracle's cloud, region, that is actually going to be supported. The communication across the connection is with IPv4 private IP address. Typically, it is going to be RFC 1918. You can use public peering to access public services within the Oracle Cloud infrastructure without using the internet. For example, you can actually use it to access object storage, the console of OCI APIs, or public load balancers in your VCN. Communications across the connection is with the IPv4 public IP addresses, and without a fast connect, the traffic which is destined for public addresses would be routed over the normal internet. But with the fast connect, the traffic goes over your private physical connection. Now you can either connect directly to Oracle Cloud Infrastructure routers in provider point of presence, which is called POPs or POPs, or you can use Oracle's partners basically to do that as well, right? Now, obviously, the Fast Connect is basically going to be good because it can provide you separate certain things. But like anything else, even for the Fast Connect, you should actually have redundancy in place so that we don't have a single point of failure, which we already mentioned. So obviously, you are going to be getting with this particular part some things to be, considered. For example, you should have multiple fast connect locations. You should use multiple routers. You should be using multiple physical circuits. The good thing is Oracle will handle these redundancies most of the times in terms of these fast connect locations, or the partners would be laying out redundant links in terms of implementing it. And the good thing is that we can implement both of these things together. So we can actually use IPSec VPN and we can actually use FastConnect together. So this is going to give us an additional level of redundancy. So we can actually have them both. So we can use IPSec VPN and FastConnect to connect our data centers to the OCI. Now, when we set up both, the IPSec VPN and the FastConnect virtual circuits, it is important to remember that IPsec VPN is going to use static routes, but the FastConnect is actually going to use BGP. And Oracle Cloud Infrastructure basically advertising is going to advertise a route for each of your VCN's subnets over the FastConnect virtual circuit BGP sessions, and overrides the default route selection behavior to prefer the BGP over the static routes if a static route is going to overlap with a route that is going to be advertised by your on-premise network. So you should be actually remembering this, that the FastConnect BGP is actually going to be taking precedence over the other things. Now, the next building thing, or the next important thing to look into, is going to be the storage. Now, in terms of the storage, again, there should be high availability that we should actually consider. But the good thing is we do have certain things actually in place already with us. For example, we should be using object storage to back up the application data. Data is going to be stored redundantly across multiple storage servers, across multiple availability domains. Integrity is actively monitored using checksums, and corrupt data is detected and automatically repaired. Any loss in data redundancy is automatically detected and corrected. We can use block volume, and we can use block volume policy based backups to perform the automatic and scheduled backups, and we can retain them based upon a backup policy. And if we do need an immediate point in time direct disk to disk copy of our block volumes, we can use the block volume cloning feature. Volume cloning is different from snapshots because there is no copy on write or dependency to the source volume in terms of this volume cloning. No backup is actually involved. Now, the clone operation is pretty fast and immediate, and the cloned volume is going to become available for the use right after the clone operation is going to be initiated. And you can attach and use the cloned volumes as a regular volume as soon as its state change is actually going to be available. And you can obviously you need to safeguard your data against malicious modifications or accidental modifications. So we can actually have the block volume available with a read-only attachment as well. So a read-only attachment obviously makes a volume read-only, so that data is not changeable or in terms of the speak mutable. And you can also use these read-only attachments when you have multiple instances that are going to access the same volume but for read-only purpose. For example, an instance might be running a web front end that serves static product catalog information to the clients. So in that case, we do not need a particular volume to be read writable. Even if it is going to be read only, it's going to be enough. Now, if your workload is going to require highly available shared storage for example, semantics, file semantics, and so, then you can actually create your particular built-in encryption and snapshots for the data protection with the file storage. File storage is going to be using NFS inherently inside it, and file storage can provide you also the high performance and resilient data protections as well. Now, the file storage service runs locally within an AD. And that means within an AD, the file storage is going to use replications and high availability failovers to make sure that our data is actually going to be saved. In case we need to go for high availability across multiple domains, then we can use cluster, FS or cluster file system on top of the block volumes. And obviously, we should plan our storage in such a way that if it is going to grow tomorrow, we should be actually able to withstand that particular growth as well. Now, the part in terms of the system, in terms of the database, we actually do need the high redundancy, or the redundancy part as well. Now, in that case, we can use two kinds of things. We can use Exadata DB systems, or we can use a two-node rack DB system. Obviously, Exadata DB systems, they are going to be having the built-in support for many of the high availability capabilities, and all the existing best practices which we have learned in case we have used Exadata before, they're all actually going to be implementable and transferable even over here. If it is going to be a two-node rack DB system, the cloud OCI architecture infrastructure does allow us to create, the same within the OCI infrastructure as well. And this is going to be done onto the virtual machine compute instances. Obviously, it does support the high availability capabilities as well, which are built on the rack capability of the system. So now, the main thing that in case we are going to be having high availability is going to be the DataGuard. And this is even more better actually for those environments where we have a single node DB system. So for solutions with a single node DB system, DataGuard is actually going to be much recommended to achieve a better high availability state. DataGuard ensures obviously high availability, protection, disaster recovery for our enterprise data. Now, in terms of implementing the DataGuard in the OCI cloud infrastructure, the database service obviously will require two databases, which one of them is going to be working in a primary role, and the second one is going to be working in a standby role. And the two databases are basically going to compose a DataGuard association. Obviously, our primary applications or most of our applications, they will access the primary database. The standby database is going to sit as a consistent copy of our primary system. Now, obviously, to improve this availability and disaster recovery, we are basically going to be good if we place the DB systems of the standby in a different availability domain from the DB system of our primary DB. So, we should have our particular primary in a separate AD, and we should have our standby in a separate AD. And the network within the particular ADs is actually going to be fast enough, obviously provided by OCI. So that means we can achieve this thing without any problems. Now, in terms of DataGuard, it is going to maintain the standby, by keeping the redo apply from the primary, which is actually going to come. And if for some reason the primary is going to be unavailable, we can use DataGuard to switch, the standby to become the new primary. And obviously, we can do the same kind of operations that we actually can do in terms of normal database. So we can do the switchover, which is basically going to be doing the reverse of the primary and standby roles. The databases keep on working. They keep on, working the way they already were working before, but there will be a role change now. Switchover obviously does not have any data loss, and we can use switchover normally for our planned maintenances that we are actually going to be doing on our primary systems. In case it's going to be an unplanned switchover, then we can go for failover, and obviously that means the transition now is going to happen for the standby into the primary because the existing primary is no longer available or it has become unreachable. A failover probably may actually have some data loss incurring for us, depending upon what kind of mode we are actually going to be into the particular system. Reinstate is basically going to have a database into the standby role in the data guard, and you can use the reinstate command to return a failed database to service after correcting the cause of the particular problem. So obviously, definitely the main takeaway is going to be that you are actually going to be good to have either a two-node rack DB system, or you can use Exadata, and definitely along with that, you should be able to use DataGuard. But if you're going to be on a single instance system, you should be actually using DataGuard for sure, where one particular DB is going to be in one AD, and the second DB is actually going to be in the second AD. Now, in terms of the architecture, which is being very highly talked about in terms of database, is max availability architecture, and many things are actually going to be there already inside the OCI to take the leverage of that. So we do have the bare metal single instance database systems, which are actually able to have the capacities and capabilities to get restarted automatically, and they can have redundant local storages. We can have virtual machine single instance database systems, which also can do the same thing. They can have the restart capabilities possible, and they're going to be having the block storages, which are going to be triple mirrored. We already just discussed that we can have a two-node rack system, which is going to be based upon a virtual machine environment. We can have Exadata-based environments, which are going to be obviously of different shapes, for example, quarter, half, full, many, many more. And we can obviously get the best of the performance from there. Obviously, we have regions, ADs, and FDs. So they are going to provide us, options in order to have, safeguard from the outages. Obviously, network is, available to us, which we can use, and the backup is available to us in terms of the object, storage. So that means that all these things actually do have the capacities and capabilities for us to achieve high availability in terms of the OCI environment. Now, there are different architectures which you can possibly pick. They are labeled in terms of this particular, three or four tiered: bronze, silver, gold, and platinum. The idea basically is, like, if you pick up the bronze, so the idea basically is that the bronze architecture is basically going to be appropriate for those databases where the simple restart of a database instance or a node or a VM is actually possible, right? You can actually do that, and you can even restore from the backups, and that is enough for your high availability or for your DR. Now, this is going to use the capabilities such as server and cluster level monitoring and the restart, which is going to come already with OCI, and it can be used with your Oracle Standard and Enterprise editions as well. Now, this is predominantly going to be a single instance capability, or maybe a multi-tenant environment as well, but predominantly this is going to be for single instance environments. Definitely we can use multi-tenant over here, and right now with all the versions, multi-tenant is actually going to become the norm. So we can actually use that as well. And this is going to be something which does rely upon the optimized backups within the OCI object storage, which are done by the RMAN to provide data protection in the same particular region. Backups are automatically going to be replicated if you're going to be using the OCI to another AD for isolations and for the protections. So obviously, using this particular architecture, what you actually can see that we do have the potential data loss pretty much actually being very, very less, almost gone down to zero. But the downtime is actually going to be still significant. So definitely, for example, if you're going to be having migrations or hardware and software maintenance to be done, in that case, the timing for the downtime possibly can increase. So that can be going into the next level, which can be silver. So the
Hi,
silver
Aman.
architect. Yes, Francisco.
Apologies. 5 more minutes.
Oh, okay, okay. 5 more minutes, huh?
Yes,
Okay, okay,
no
okay.
problem.
Sure, 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 sure. I think we should be okay. So the silver is basically designed for databases which are not possible to afford to have a cold restart or a restart from the backup in case there is going to be a problem. And the silver is basically going to start with the bronze, but the capabilities of the bronze, but it is going to add, different things as well. For example, we can use rack actually over here. So obviously, we will not be requiring to go for the cold restart or immediate restore from the backup, because we have a secondary system to actually work for us. And obviously we can be using it along with the VMs or with the BMs of Exadata as well. And we can use DataGuard also, and that also can actually help us. So again, in terms of doing this part, you can actually see that a lot of information is going to be, or a lot of capability is going to be remaining the same. But if we notice the RTO over here, now it has actually come down. So for example, in case of online file moves or fault domains, it is in seconds. Such kind of maintenance and patching, they are almost gone to zero. Upgrades and such, they are still actually going to be having some time delays. Now, the second thing is going to be in the same particular part is the fast start failover. So that actually can be useful, the fast start failover part. So this is basically going to be, good. And this is basically going to be recommended when we are going to be requiring to have, the failover also actually to be done very, very quickly. Again, over here, this actually can help definitely in terms of RTO. Now, the last two are actually going to be the gold and platinum. So in terms of the gold, we are going to be using it for those particular environments where the SLA cannot tolerate any kind of delays or downtimes, or the timing for the recovery has to be very, very quick. And this is basically going to be built on the same rack, but we are going to be using Active Data Guard actually over here. So obviously Active Data Guard is going to be always operational, so that is going to be helping us in terms of getting the high availability part very, very quickly. So again, if you're going to be using that, again, this is going to be good. But if you're going to go to the last one, which is actually meant for the extreme critical systems, this is going to be possibly the ideal thing. So this is basically going to be built upon the gold architecture, but it is going to be having the extra layer of protection or redundancy deployed by us on different levels of the system. So this is going to be using Golden Gate. This is going to be using addition-based redefinition, and obviously this is going to be meant for those environments predominantly which are going to be not at all actually able to withstand any kind of downtimes or delays. And obviously over here, things are going to be looking pretty good. Everything is going to be coming into almost zero. Now, the final words, and I think we already are running out of time. So final words is definitely that high availability is going to be one of the most important aspects when we design our infrastructure. Uh, Cloud infrastructure does have all the options, but it is very important to play with these particular options even for some time. So the best way to do that is, in my opinion, that you should actually get the free tier access. And in the free tier, you do get the 30 days of access for this particular OCI console and the OCI services. And after that, also a couple of services remain free for the lifetime. Do actually check them out and try to implement things basically over there. There are going to be some restrictions still, but still having it available for you, even to play around, is actually going to be really nice. So that's pretty much it. I am available mostly on the Twitter. I tweet, I look at the tweets and I'm very active on the Twitter. So if you're not already following me, do follow me over there, and we can interact for any kind of questions or doubts actually over there. I blog here. You can reach me out over here. So that's pretty much it. Thank you, and thanks to the team for organizing it, and I hope it was useful. Any
Hi,
questions?
Aman. Thank you so much for your great session, like always. I'm just checking the Q&A tab, and we have no questions. I will give you a few more moments in case anyone want to place any questions.
Sure.
But as I mentioned before, this session will be available as a playback for 2 weeks from today, and the assistants can then place posts and comments if they have any issues, and you should be notified by the system. If not, I will let you know. And I recommend everyone assisting the session and watching recording also to tell your friends and your peers that they can register and have full access to all the content of the conference with the recorders and the live at any time. And no other questions, looks like, Aman, and I leave you to have the rest of the day off and work and do your own stuff. And once again, thank you so much for your contribution to the community.
Thank you so much for having me, Francisco, and thanks to you for all the great help and doing it for the community. Thank you.
Thank you. Bye, everyone.
Bye, everyone.